Hello everyone. In today's session we are going to cover with the aerodynamics of vehicle. So let us understand one by one. So what topics we are going to cover? First of all, we'll understand the theory of lift or a down force. So how the forces are acting on any object. Drag concept, what is exactly drag, and some aerodynamics devices, and also the aerodynamic applications in Formula 1 car. So what is basically aerodynamics? Aerodynamics, it's a branch of science which deals with the motion of object in air. Suppose we have any object, it is moving with certain velocity, so air's interacting with air, so that will produce a certain kind of effect. So that is what we are going to study here. So considering the object is required object is a car. So let us see how we will go ahead. So in order to understand the theory of lift, the drag concept, we should have a certain information about the fluids, properties, and some principles also, means some principle behind the fluid. So we will cover one by one. Let us move ahead. So first of all, let us understand what is aerofoil. What is aerofoil? The object or geometry, a kind of geometry you can write, the object which can produce aerodynamic effect. Aerodynamic effect. What is aerodynamic effects? Means either lift or down force, or also you can say drag. So this is considered as aerodynamic effect. The effect produced by air when it is interacting with any object. So that effect is called aerodynamics. So that is considering lift, down force and drag force. Any kind of effect if the object is producing, so that is called basically the aerofoil. So aerofoil section, let us understand this first. So suppose we have an object, this is called aerofoil. So first of all, let's understand the nomenclature of this. So this central line, not a central, upper line is called upper camber. Upper camber. Bottom line is called lower camber. Sorry, it's a camber. And this one is called leading edge, and this one is called trailing edge. This one is called leading edge and this one is called trailing edge. This one is upper camber, this one is lower camber, and the central line is obviously, it is called chord line. So what is chord line? Line joining between leading edge and trailing edge. So this one is what? Chord line. It is joining the trailing edge and leading edge. Okay, so this is the basic nomenclature of the any aerofoil section. Now we will understand how the process of generation of lift is started. Let us understand. Air is a what? Air is basically the compressible fluid. What is it? Air is a kind of compressible fluid, or you can say collection of molecule, collection of molecules. So what will happen when the air molecule is moving? They have certain kinetic energy. They have certain kinetic energy if they are flowing randomly like here. And when they are like colliding with some other objects, so this kinetic energy is changing into kind of pressure energy. We'll understand later how it is going on, the entire process. So, which kind of forces is acting on our vehicle? So, we'll understand four forces. Four forces. What are the four forces? Let us see. This one is a car. So what are the four forces is acting there? Weight is acting vertically downward. Thrust acting there. Lift force is acting there. Drag it acting there. Let us understand one by one. We already know about the thrust. Thrust is what? It is basically power produced by power plant of vehicle. Maybe electrical vehicles or other vehicles. And the weight is, we know already. We need to understand the drag force and the lift force. So lift it is what? Lift is primarily we can define it like the force acting on object cause the or providing upthrust. Upthrust means thrust in upward direction. And if you like to define what is drag exactly, so drag we can write, it is produced by air only. Opposite forces acting to what? Forces acting opposite to thrust due to air. So that is basically called drag force. Now we will understand how the lift is creating in our vehicle. Next one. How the lift is creating. Let us understand the theory of lift. Many theories are like currently are in our practices, but maybe some of them are incorrect and some are really correct. So we'll understand both theories, which is incorrect and which is correct. So suppose we have object something like this. Okay. So initially what will happen if the air is coming, some air is going bottom side and some air is conducting from this side. The object is here between that. So when air is acting on here, so air molecule is applying the pressure or a force on particular point. So that is pushed by downside by the object. Okay. So in order to tackle that forces, air molecules also applying a certain force in opposite direction to the force produced by the object. So what will happen? Because of this, object will try to lift. So this is what the conservation of momentum. First one is what? The conservation of momentum. Conservation of momentum. So initially, like this is not a wrong even. Any kind of object, suppose this one is an object. What will happen if force is acting here? Air is coming this side, some air will go down and some air will go up. They are meeting on same place in behind some at certain point. So what will happen when the air is interacting to these surfaces and these surfaces are pushing down air? So air is also applying a force in opposite direction. So this is what the conservation of momentum, or you can say this is what because of third law of Newton. Third law of Newton. Okay. So if you are considering an aircraft, see aircraft, a very small aircraft, suppose like this, very small aircraft. So what will happen here? On the entire body of aircraft is producing lift force. First of all, you need to understand the air is passing from these points are creating the lift force. Certain air is going downside, and this object is pushing air down. Every part pushing down. So in order to, the airs are applying a force on aircraft also, which is trying to lift this. So this is one reason you can understand. I hope it is clear. If this point is not able to remember, you can remember the third law of Newton. So air is applying a force on this, and this is also applying a force on air, or object is trying to push the air in downside, so air is pushing the object in upside. That is why the object is lifting up. Now let us understand some incorrect theory. Which one is incorrect? Incorrect, let us understand which one is. This is called equal transit. Equal transit. What does it mean? Suppose this one is a object. Okay, so air is passing from here to here, and this one is upper camber. So upper camber, it has a higher length from here to here, if you know, and this one is a shorter length, quite shorter length from here to here. So according to this theory, the air is coming down, is taking very less time. In order to reach on same time at the trailing edge, this air have to move faster, and move faster air is creating the lift in this direction, like. So practically it is not possible that same air which is coming from here to here and here to here, they are reaching at the same time. So that's why it is incorrect one. And again you can understand, suppose we have a flat surfaces like this one. Even this one can create a lift, but here air coming downside or coming upside, the length from here to here is what? The same. So this, if they are reaching at here at same time, so that means that air is not creating any kind of lift, which is wrong. You will get either lift force or down force at this particular surface also, either down or lift force. So this equal transient theory is primarily means what? It is incorrect exactly. So this is not explaining the way. Now let us understand. So you all familiar about the Bernoulli. So he has given the right explanation about the lift forces, or you can use the principle of Bernoulli. See what he has given. Suppose we have a pipe, this one. So what will happen if the air particle is passing from here, air or water or any fluid particle is passing from here? So rho into area into velocity is here is equal to constant. That is what? This is the equation of continuity. Equation of continuity. So that means what? Because if we are considering any fluid, the density of fluid will be constant. So here we can write area into velocity is equal to constant initially. Okay, let us take another example of this to understand this in better manner. Now the same pipe, we have decreased the area here. You can understand, not like this, like this. If the same amount of air is now traveling here, what will happen? Here we have decreased the air here, area of pipe we have decreased here at this particular point from here to here. So the velocity we are decreasing there, the velocity at that particular point will increase here. So if velocity at particular point will increase, and you can observe if you are squeezing the pipe containing water, if you are pressing here, what will happen? The air flow rate will be faster. Yes. So this is also called Venturi effect. Venturi effect. And again, after understanding this one, so we have one more equation of Bernoulli, that is saying what? P plus half rho V square plus rho GH is equal to constant. This is the theorem given by Bernoulli. So what does it mean? This is saying, this is again the form of conservation of energy. Which one is form of conservation of energy? So let us understand one by one. Suppose this pipe has an equal area, equal height from here to here. So this H will be constant, G will be also constant, and rho density of fluid will be constant for a particular fluid. So this reduced equation, we can reduce this. What we can write? P plus half rho is again constant. If you want, you can carry, otherwise no. Half plus V square is equal to constant. Means that everything now is depend upon the pressure and velocity. Now what you can do, if you don't remember this equation, this is like a Bernoulli's theorem. So now what will happen if we will increase here, just remember this, we decreases the area at this point. So velocity at this particular point has increased. So what will happen if velocity is increasing, the pressure is decreasing at particular point. So in a dynamic fluid, So in a case of dynamic fluid, what we can conclude, just see here at this point, focus here, focus. What does it mean exactly in a dynamic fluid? Remember, for a dynamic fluid, what will happen if we are decreasing the area? Velocity is increasing at that particular point, and when velocity is increasing, the pressure is decreasing at that particular point. So we can say area is directly proportional to pressure. That means we are increasing the area, the pressure is increasing, and if we are decreasing the area, that means pressure is decreasing. What is going on here? If we are increasing the area, so that means velocity is decreasing, and so if velocity will decrease, what will happen? If velocity will decrease, so pressure will increase. So velocity decreasing, that's why pressure is increasing, and here also, and if here velocity is increasing, so pressure is increasing, so pressure is decreasing. So this is what we need to understand. And now we know that pressure is what? Force upon area. Pressure is exactly the force upon area. So this is valid for the static fluid only. In case of motion, we will consider this one. So that pressure is what? Half rho v square is also a pressure. This is called the dynamic pressure. Okay. So no problem. I hope up to this point it is clear. And why we are looking for, because we are learning currently the theory of lift. So this is what the principle behind how the lift is creating. Now if you learn this, we'll move ahead. So up to this point, what we understand that if the velocity is increasing, so pressure is decreasing. Simple. And velocity is decreasing, pressure is increasing. So what will happen if this is going on with respect to certain fluid and object? So that, note one point, this is very important. The object, what we will write? Object will move towards where there is less pressure area, where there is less pressure area. Less pressure area. What does it mean? Less pressure area means what? See, I am taking example of object. Suppose this one is object, and consider this one is what? The full area from here to here. So what is going on if object, if air is flowing on this side and this side like that? So look, take an easy example. This one is a kite. So some air will flow from upside and some air will flow from the downside of the kite. What will happen? Still the kite is taking up. So what will happen? The air passing above the kite having velocity is higher, which is decreasing the pressure, and that is reason why, because pressure downside of the kite is higher and upside of the kite is lower, so that's why kite is moving from here to here, upside, and also air is applying a thrust on the surface of kite, on a face of kite. So this is the reason why, suppose kite is here now, so what will happen? Air is applying the force here, that is the additional thing. Another one, air is passing on that, creating a less pressure area here. And this particular thing you observed near the metro station or railway platforms or metro platforms. So suppose this is a tunnel. If metro is underground, suppose this one is tunnel, and this one is a platform, and this one is what, consider the yellow line is here somewhere, yellow line is here. The announcement is continuously going on, please stand away from yellow line, away from Y line. Why it is? Suppose this particular point is low. Suppose this one is metro is coming here with a speed of 80 km/h. What will happen? The air is coming with metro. It is also considering 80 km/h. So between this one is a platform, this one is yellow line, and if you are standing here somewhere, what will happen? There is a certain pressure, and when the air is moving so faster between you and the train, what will happen? Because of higher velocity, pressure at this particular point will decrease and this air will try to suck inside. So there may be the chances of accident. So the announcement is going on because this yellow line is a calculated distance from here to here at that particular maximum velocity of metro train. If you are standing away from that air will not able to suck you inside, will not able to pull you inside that particular. So because less pressure is creating kind of force. If this is a like certain kind of vacuum, so what is the nature of vacuum? That will try to suck the object towards them and try to pull the object from this side to vacuum side. So this is what the effect of pressure, less pressure or higher pressure. Okay, so this is the exact theory behind the lift. Okay, let's move ahead. Now I am considering an object here, one object here like this one is object. Okay, so technically this one is again a center of line. I am giving the, so what is this? This is called boundary. This one is boundary. Like after this point there is no effect of moving this object in air. That means air is this can disturb the air up to this point and this point. Fine. So what is happening here when this point, if the air is coming in this way and going down, certain air and certain air from upside, this is moving like, so at this particular point at the maximum curve, this is called the center of pressure. You can say this one is called center of pressure. Center of pressure. You can now note this point. Also, center of pressure is also you can say center of lift also. Center of lift. Fine. No, just move ahead now. What will happen? If the air is interacting here, the net force is acting in this direction. Like air is coming like, so it is pushing object, F is acting. So we will get two components of air. This is called lift component and one component acting in this side. This is called drag one. The force component, this force is acting this side and one force is acting vertically. So two component of this particular force, one is called drag and other one is called lift one. So you can remember. See. Take one more vehicle here like this. Car, kinda. See, if air is coming, attracting here. So suppose this one is the point where center of lift is working Down force is acting, what will happen? The force is acting in this direction. So one component of force will be this side, another component of force will be this side, and the opposing force is called the drag component, and this one obviously it is called lift, your lift component. Okay. So in case of car, we will not create this lift. We need everything, not a lift, we need a down force, not a lift force. We required. So if we understand how lift is creating, so we can also, if we can create lift, so definitely we can create a down force. If this kind of geometry is creating lift on any object, so if we will reverse it like this, if we reverse it, so this kind of geometry will start creating the down force also on the same object. So in F1 we are using spoilers. We are using spoilers. Where we are using it? Just a minute. Take another one. So suppose this one is a car. I am considering a car, not F1. Normal car I am considering here. A normal car I am considering here. Suppose this one is what? I have taken the bigger one so that you can understand. So this one is what? So this one is a spoiler here. So what is going on with this spoiler? The air is coming, it is interacting here, this is pushing down air here. This is pushing down, reducing the velocity of air, reducing the speed of air. Speed of air, reducing this. So air is moving downside here, so applying the down force on this particular car. And also in F1 we are using the wings. We are using wings. Let us understand this one by one. We are using the wings and spoilers. They are working on the same principle basically. So this is one kind of wings, and spoilers are kind of aerodynamic devices that we will discuss later. Okay, so let us understand, let us design a car for a full analysis. I have designed it for the purpose of full analysis. Okay. This one is ground. I am taking the upper boundary. Beyond that boundary, no air is interacting with them. So what will happen? Let us flow the air. Air is coming, compressing here. Air particles will compress here, will apply the force in this direction also. So the kinetic energy is converting into the pressure energy here at this particular point. So this is applying force here, that one is called the drag one also. And when this air will come onto this bonnet, what will happen? Frontal area, you can say this one is frontal area. Frontal area. So speed of air, again you can see the speed of velocity of air here increases. So because also why velocity is increased? Because of this flat surface, and also the area here is higher and area here A dash is lesser comparatively. So velocity is increasing, so pressure is here decreasing, so that the bonnet will try to lift. And again when air is coming here at this particular point, area is again decreased, so velocity at this particular point will increase, and when velocity will increase, the pressure at this particular point also decrease, very fastly decrease. So what will a lift will create here? Will try to lift this object at this particular point, and some air is going downside also. So ground clearance is very much important. How much is ground clearance? In F1 you can see ground clearance effect. I will explain ground clearance, how it is playing important role in aerodynamic. Ground clearance, basically less ground clearance. That means if ground clearance, suppose this one is object, I am not constructing the upper portion, this one is object, and ground clearance is very less, like this. So what will happen? Very less amount of air will enter here, and also because area is very less, area is very less, so what will happen? The velocity at this particular point will be very high, and velocity will be high, that means pressure will be very less, very less, right? And if pressure will be less here and pressure will be higher here, pressure is high here, pressure is less here, so what will happen? This force will act in this direction, from high pressure to low pressure. So that means on a Formula 1, automatically we are generating a down force, not a force in this direction, but force in downward direction. So if this particular section will be higher, so that's why in racing cars ground clearance is very less, so that less amount of air can pass. If air is not passing from here, what will happen? This area will be considered as a vacuum. So vacuum, this will try to pull this entire object towards her. So that will be the best thing. But it is quite impossible to resist the entire air from here. If there is a space, the air will come to down. Okay. But maximum air in F1 with the help of multiple wings on both sides, the maximum air we are trying to resist. Okay. And at this particular point, no air is here, so this is creating a kind of vacuum, or very less amount. So creating a kind of vacuum here, and this one is really dangerous for a vehicle. High vacuum area means high drag. Remember this, high vacuum area means high drag. High drag. How vacuum area means high drag. So this one will try to reduce with the help of a spoiler, you can say, will push down the air here. So what will happen? If the vacuum area is high, this will try to pull the object backside also. Apart from this, these things, air will pull this object also backside. So this is about the design analysis of object into the air. One more thing we need to cover, that is what aerodynamic devices. So that we can learn from the, just a minute, from we can go for the sum. We'll see this one. I have opened this aerodynamic device. See, this one is a no problem. So this one is basically called a scoop. Okay, this one is called a scoop. One thing, this one is what the flaps. This one is called flaps, also called frontal wing. Frontal wing. So this is trying to lift the air upside, not a downside. And also this is a layer by layer. Some air is going inside and they are passing from here. They are passing from here. And this is again a spoiler. This one is what? Is spoiler. Okay. So this one is again a spoiler. So this is pushing down the air bottom side here, like this. This one is a scoop again. So you can see here the wings, scoop, spoilers in Formula 1 and see this one. Very less amount. Around 0.5 inch, even less than 1 inch, the ground clearance here. This is playing very important role. Again, I'll place some more. No, back. Some more images, not there, no problem. So let us understand, we have one more thing called NECA ducts. NECA ducts. ducts. So this is using, first of all let us understand scoop is also there. The vehicle is here. We understand in previous analysis that on particular bonnet, the object is here, one object is here. Scoop is basically the increasing area diameter device, like this. We can place it on bonnet like this. So in commercial cars it is placed on at this particular point. So air is coming into this. So high velocity air is coming into here. What will happening? Area is increasing, so velocity is continuously decreasing. And one more important, this one is directly opening into the engine segment. So providing the additional cooling as well as decreasing the velocity of air. So at this particular this particular section, so that's this down force we can get. Okay, not a lift kind of force. So NECA ducts and scoops, and this if we are using this on a side of the car, some sport cars or supercars, you will see this same device is acting on a rear wheel here, both side of the rear wheels. This one is here at this side and this side, so that is particular called NECA ducts. The principle is same. This is again a increasing diameter device, like this. Air is coming and try to resist the air. So this is about the devices. So these devices are using somewhere to reduce the velocity of air. For what? Velocity of air. To reduce the velocity of air, we are using it. And sometimes we are using it to provide lift. If it is, we are using it in a car or in skyscrapers, even in Burj Khalifa, they have used multiple wings and scoops to resist the air or to avoid the air interaction. This is also providing the lift if we are using wings. In aeroplane we are using lift, and in Formula 1 we are using downforce. So we need to understand, as per our requirements, we are using the effect of air. So for any kind of inquiry and all, you can reach me out in any doubt clearing session and all. Thank you so much. We'll meet in the next session.